In this tutorial, I'm going to show you how to turn almost any image into amazing multicolor 3D prints like this one by converting them into vectors. Let's get started. So as you've probably noticed, multicolor and multi-material 3D printers have come so far in the last few years. And the last time I talked about converting images into 3D geometry for 3D printing, multicolor wasn't even a thing, so I wanted to revisit the topic. And this tutorial, I'll be talking about all the different things you need to know if you want to make amazing multicolor 3D prints using your own images. But first, I want to clarify, this is not a tutorial on how to create QForge style images. They look amazing in their own right, but this tutorial is very different. I'm going to show you how to turn images into vectors that you can import into your CAD software, and then use those vectors to create geometry that can be used in multicolor 3D printing processes. To do this, you'll need Inkscape. This is a free open source vector drawing program. It's incredibly powerful and it's completely free. And for the 3D modeling, I'll be using Autodesk Fusion, but you can also import vectors as an SVG into FreeCAD. So if you're using that program, then a lot of what I'm going to be talking about in here will still be applicable. And the magic format we'll be using to convert our images into 3D data is SVG, or Scalable Vector Graphics. These images are very different to the standard JPEG or PNG that you might come across for images because they can be scaled to any size without losing clarity. And that's because these images are comprised of curves and geometry within their file, and they can be scaled without any degradation of image quality. This tutorial is actually made up of lots of mini tutorials, and there will be timestamps below. For the first part of this tutorial, I'll be talking about how to create the SVGs themselves. Getting these SVG files to import into Fusion at the correct scale is also fairly tricky, so there's a section on that. And then I'll be talking about 3 different methods you can use this vector data to then create geometry for multicolor printing. And finally, we'll be going through some troubleshooting steps if your vectors don't behave, because things can go haywire fairly often. There are many places you can look online to find free downloadable SVG files. Be aware though that when you do search for SVGs or free vectors, often you come across websites that will show up in the listings, but they're not, and they want you to pay or go through sign up pages and that sort of thing to get the files. But this is just one good example that I use all the time for freely available icons and simple SVG vectors that you can then use for 3D data in your models. When it comes to choosing your vector files to use for multicolor printing, you want to keep them simple, and at least for this tutorial, one color, so black, is ideal. You don't want to be choosing ones that have any gradients or anything because you can't really print that. And choosing ones like this pack here with different colors in them are very possible to do, but definitely need a level of knowledge in manipulating that file because it's not going to be ready to go within Inkscape or another vector editing program. So for this, we're just going to be choosing a simple black vector. And I quite like this hamburger here. So hamburger SVG vector, and I'm going to download that. But before I dump my hamburger vector file into Fusion, what I want to do is first open it up in Inkscape to get a good look at how the vector's been arranged, because it's really important to be aware of how it's going to be interpreted into Fusion, and we can clean it up within Inkscape before proceeding any further. And here we have the hamburger vector. Now, it's really important to be aware that it's only going to be interpreting the outlines in your CAD program. So to get an idea of what that's going to look like, over here on the right-hand side, I'm going to be turning fill off for this vector, like that. And instead, turning the stroke on, and I'll turn it down really thin to a thin so I can see it. Alrighty. So this is a better representation of what's going to be imported into Fusion. And this is what's going to be used as the geometry to cut in and add our multicolor information. I can choose to see the nodes. Now, vectors are actually mathematically driven curves, like a spline, basically. They are splines. So you can actually change and adapt them to suit what you need. So you can actually edit this to suit your needs, and you could add or delete information. But this isn't an Inkscape tutorial. This is just to show you how to understand vectors. And this is one very easy way to get access to a whole range of SVG files. But what if you want something custom, something personalized? Well, you have to draw it yourself. And that's where number 2 comes in. If you wanted to create your own SVG file for use in multicolor, I'm going to assume you're either doing a logo or using it for text. and text is an excellent use case of this technique. Now you can do text within Fusion directly, but there's very limited controls and fonts and options, and you can't do the sort of fun warping and outlines and offsets that I like to do with the text that I use in my design. So that's why I use a vector editing program like Inkscape. I'm gonna go over to the left-hand side with the text tool, click that there, and just say like that. So it's still got the outline showing, not the fill. So I'm just for the sake of drawing it, I'm gonna go back to showing just the fill, like this. I can change my font. Let's try Lonely Coffee. I like this one, it's fun. Now from here, before you export as an SVG, we need to convert this text into outlines like the previous vector was. And to do that in Inkscape, you go up to Path, and you want to select either Object to Path or Stroke to Path, depending on what geometry you've created. Now, Stroke to Path works well for text. So it looks like nothing's changed, but if I go here and turn Fill off and turn Stroke on, you'll notice, make it thinner again, that we've now got the outline of our text. And if I go to the node tool on the left, it's created all these little nodes. So these are all the nodes that dictate these vectors. And you can manipulate this and edit it to your heart's content. So I could grab the A, for example, like maybe the top of the A, and move it. A bit hard to grab it. Move it like that. Maybe the bottom of the insert there. Move it down there. Grab the top of the K. Shift it over there. And you can see you can actually start to have a lot of fun with these little node points like that. And then once you're happy, we can export this as its own SVG. So on the top right, you'll have a drop down here, export. If it's not showing here, you can actually add it in. So over here, furthest on the right, you can choose to show what windows or tabs pop up. So export, and then down the bottom, you're gonna choose plain SVG is totally fine. Save that off, and then that is the second way to create SVG files. The third method of creating an SVG file is probably the coolest, and that is to use Inkscape's tracing abilities to actually convert images into vectors. So convert images with pixels, it'll actually try to figure out where the edges are, and then convert that into a vector layer, and then you can tweak it further from there. So for example, let me just search like, poor print vector, right? So if you search hard enough, you'll probably find the SVG for this, but a lot of these sites like iStock Photo, they'll show up, but you have to pay or log in to get those vectors, but they're quite simple, right? So let me zoom in. This one here is actually quite a simple shape, but it's an image, but that's okay, because we can use Inkscape to trace this image into vectors, and it's really, really easy to do. I'm going to use the snipping tool to just grab here and go around that paw pad, copy that, then go back over to Inkscape, paste it in. Now, ideally, the sharper the better. You want a nice crisp edge, but it will still totally work in the image that's been blown up and pixelated a bit like this. So again, over on the right-hand side, we have these drop downs, and we're going to go to Trace Bitmap. There's a lot of different options. Now, you can actually trace multicolor images into layers of different vectors that you can then manipulate to create really complex multicolor layers in your 3D modeling. Way too advanced of a tutorial for this introduction. So we're just going to simply be using this brightness cutoff tool, and we're going to be manipulating the slider to get a nice smooth shape. So let's see what the threshold looks like that. And then we want to optimize it to try to cut as many nodes out as possible, because the tracing bitmap tool can create a lot of nodes, and too many nodes in your SVG can crash your CAD software. Ask me how I know. So I'm quite happy with this preview. So I'm going to say apply. And this was the traced result. Now it's not perfect. You can see that the nodes have tried to follow the shape, and it was fairly low resolution. Again, better resolution the better. But we're going to be printing it at the end of the day, and 3D printing definitely doesn't have a very high resolution. So I think it looks pretty good. If you wanted, you could go through and edit the nodes as you see fit, just like the text example. You can go through and choose these different points. You can choose their strength and the direction. Like if you want these claws to be, a bit taller like this, you can grab these here. Maybe make them a bit thicker, like so. You can do that sort of thing to get it exactly how you want. And just a sanity check that generate vectors will work. Again, I'm going to select everything and I'm going to turn off the fill and then turn on stroke like that. And again, make it nice and thin. You see that we've got these nice continuous outlines, which will be necessary to use them in Fusion. So you've created your SVG. Now it's time to bring it into Fusion to use that vector to create solid geometry that you can then use to influence your part or make awesome multicolor models. So to do it, it's very simple. I have a blank workspace, blank document opened here on Autodesk Fusion. And then here we have Insert, Insert SVG. And I'm going to select my SVG. I'm going to choose the hamburger that we downloaded. And then I'm going to select the plane I want to put that on. I'm going to select the top plane like this. And then it brings it in, showing just the outlines. Remember, that's what's used to influence the solid geometry. And I can move it around like this. I can scale it like this. Let's make it that big, whatever, then put it there. And you notice the lines are green. That means they've been fixed by Fusion, so you can't move them. If you want to move them, you have to right-click the lines and then say unfix, then you can. But really, you shouldn't be trying to change them now because the best way to make it exactly what you want is to use the correct vector editing program, which is Inkscape. And we can use these vectors to create solid geometry. So I can select the outline here, and then I can go to solid extrude, extrude it up like 2 millimeters, and I've got a solid geometry hamburger. Like that. But you're probably already screaming at the screen because we have one big problem. What size is this? What scale is the vector we've brought in? How do you make sure that it's correct with what you want out of Inkscape? And I'll be honest, it took me way too long to figure out the workflow to do this correctly because the way it works in Fusion is kind of terrible. Fusion will import an SVG assuming a DPI of 96. That's a dot per inch pixel density for the SVG file of 96. So that's going to determine its size. But it also requires the file that you've saved to have pixels as the unit that it's been saved as. So let's go back to Inkscape. I'll show you where this can mess you up. So I've got this paw here, and it's showing that it's got a width of 97, height of 108. Let's just make it 100 like that. That's cool. So you would think exporting this, I've got export DPI of 96. You would think this would export with a height of 100. Let's just see what happens. It imports totally fine, but if I draw a bounding box around it, you'll see that, yeah, it's not 100 millimeters high at all. It's 30 millimeters high by 27. So what's up with that? Well, in Inkscape specifically, I've found it doesn't always happen in other vector programs. You need to make sure that the units of the document are also pixels, not millimeters, which is what it's defaulted to here. So to make sure that's correct, go to File, Document Properties, and here for the file's units, we want to make sure that it is pixels. It has to be pixels. And under Scale, it has to be 1, like that. It can't be anything else if you want it to bring in correctly. So I've done that. Now what's going to happen, it's going to just scale our paw again, annoyingly. So I'm just going to scale it again to make it 100 high, like that. And now we've got the document in the proper units, and I can export it again, making sure that it's 96 DPI. And there, as you can see, it's actually brought it in at the correct scale. You can see that it's 100 millimeters high, like that. So to recap, if you want to bring in SVG vectors into Fusion at the correct scale, you need to make sure, number one, that your document's units are in pixels. And when you export, you need to make sure you set the DPI to 96. Alrighty, so with that out of the way, I'm now going to walk you through the different methods you can use this SVG data to create multicolor 3D printable models. This first method is to create separate bodies within the same 3MF or STL file, and then in the slicer, assign a different color or extruder to them to create the multicolor model. This is by far the most universal method and the oldest method, but it's definitely not the best, as you'll soon see. So to demonstrate how to do that, I've still got my paw pad here, and I've done just a solid bounding box and extruded it down 10 millimeters. And from here, I want to now create some new bodies. So I'm going to go select extrude again, and I'm going to select these separate areas here. But instead of doing an extrude cut or adding geometry to this solid body, I'm going to make them new bodies, like this. So select new body, and I'm going to make them go into it by, let's say, -2. So I've got new body selected, and I'm going to say OK. And you can see on the left-hand side that we now have all these new bodies that have been created, like so. And just to be safe, I'm now going to do a Boolean difference, or in Fusion it's called a combine, to cut away these separate new little bodies from the main one to make sure there's no intersections, just to be safe, because you don't want intersecting bodies in your slicer. It can lead to very unpredictable behaviors. So just to do that, I've got the target body, and then the tool bodies will be all of these little ones that I've got here. I'm going to do a cut, and I'm going to select keep tools, so it preserves them in the file, like so. I'm going to hide the sketch, and here you can see I've got those little bodies, and then the outside one like that. Okay, I'm going to save this off as a 3MF, as a single file, like so. And now here over in Orca Slicer, I've brought that file in, and it automatically says that the file contains several objects positioned at multiple heights. So what I want to do is I want to make sure I want to consider them as multiple parts of the same single object. So I say yes, like that. If we go to objects here on the left-hand side, I can then assign different extruders. This is the tool changer of the SnapMaker U1. I can assign different extruders to different body parts, like so. That is a very bright red. Let's go with something a little bit less bright. There we go. Nice. And if I say slice plate, it'll show you that this will be printed in multi-color. We've got one tool doing the outside block, and then I've got another tool doing the little paw print bits, like that. And because I did the combined cut, or the Boolean difference in Fusion, these edges of these parts mate perfectly with each other, like so. This method of creating multicolor objects for 3D printing works on many, many slicers. Not just Orca Slicer, not just Bamboo Slicer, it works on Prusa Slicer, and I haven't tried Cura, I'm sure it works on it too. It's the oldest method of doing this kind of thing. But the other two methods I want to talk about are arguably much easier and better, but you do need a slicer that supports it. Instead of creating multiple bodies that you then assign different colors or extruders to, you can instead cut into the shape just a little bit to create geometry that you can then color in the slicer and then add multicolor that way. But you cut it in such a small amount that doesn't even register as a different layer height, so it actually ends up with a completely smooth plane just with multiple colors. And I've tested it many times and it works really well, if not just being a little bit dodgy. So I've just deleted those multiple bodies, and I've got the sketch of the paw pad here. I'm going to do a extrude and select those little areas that are enclosed. And what I'm going to do is do an extrude cut, but it's only going to be 0.05 down. So minus 0.05 down into the block, a tiny, tiny, tiny cut. So I'm going to hide the sketch, and it will show that these are now separate faces. There's a tiny, tiny, tiny ledge, right there. And this ledge will mean that these little details are preserved in the geometry, even though it's really small, if I export as a mesh. And although these differences in height are minuscule and they won't show up in the 3D print, they can be used to add separate colors in. Once again, I'm going to right click, save as mesh, save as a 3MF file. And this time when we bring it into Orca Slicer, it doesn't actually show multicolor because it's just one object. But instead, we can actually use the color painting tool and use the fill option to then fill these little tiny areas that are subtly different in height, but therefore defined with a separate extruder color. And it's really easy to do. Just select the color or extruder you want to fill in. So I've got number 2, which is that nice pink. And I click there, there, and there, like so. And because this is only adding color to the surface of those areas, it's not creating a separate body that has color extended deep into the part by an arbitrary amount. This is arguably a better way to do it, because if I show the G-code preview and scroll down, it'll actually only be adding color just at a certain depth to make sure that it's rich enough without any color bleed, but it won't be adding it any deeper. And this actually works really well, even on curved surfaces and that sort of thing, because why wouldn't you take advantage of a tool in a slicer like this if you can? I find this method a lot less fiddly than adding separate bodies and that kind of thing, but this won't work for multi-material 3D printing. For that, you still need to create the separate bodies and then assign those separate bodies to separate extruders. this is not suitable for a multi-material 3D print. However, there is one more incredibly powerful way of using your SVG vector data to create multicolor 3D prints, but it will only work with Bamboo Studio or Orca Slicer because it's based off Bamboo Studio. And that is to export your file not as a 3MF, not as an STL, but as an OBJ with a material file attached, which will assign different colors to that mesh. The setup takes a little bit longer, it's a little bit complex, but man, is it powerful. Once again, I've gone back to square one. I've just got this solid body and the SVG of the paw. And what we're going to be doing is actually using surface bodies, which I've talked about in previous tutorials. These are zero thickness surfaces, and using those to cut the top surface face of this block and assign color to those areas that are being cut. So imagine these outlines, right? You can assign color to these faces in specific areas if you cut it. What we want to do is go to Surface, and under Surface, we're going to choose a Surface Extrude. So the Surface Extrude we can use to select all of these outlines. You can do all of them at once, like that. And you can see we can bring them up into these nice zero thickness surfaces. But I want to make sure it's intersecting that top surface of the block. So I'm actually going to go the other way, like this. Just for clarity, I'll actually probably extend it both ways. But you just need to make sure it's actually intersecting that top surface. So say OK, like this, and now we've got all of these new surface bodies that are being added to the file. Now what I'm going to do is I'm going to go to Modify, and I'm going to choose Split Face. And with Split Face, we can select that face at the top that we want to split. And then the splitting tools, we're going to select all of these surface bodies, like that. And then, OK. And once I hide those surface bodies and the sketch, you can see that this surface for the block has been split into separate parts. And what this allows me to do is I can right-click the block and go to Appearance. And then I can add a separate new appearance by just duplicating the first one. I'm going to give it a color. Let's go red. Looks good. I can now add this color, this new appearance, to just certain areas of this face, not the whole thing. So I can go and select this area, and this one, this one, this one, and this one, like that. Doesn't really matter what color you choose, and you can do several different colors, but keep in mind you'll be limited to how many colors your 3D printer can reproduce. So for example, on the Snapmaker U1, there's going to be 4 different tool heads. I'm limited to 4 different colors that I will be interpreting into the slicer. Now, if I save this off as a 3MF, for example, you'd think it would preserve this extra color data because 3MFs can and do preserve material information. And I've got the 3MF opened in 3D Viewer to prove my point. The extra color information's been preserved. But if I bring this into Orca Slicer, it just shows up as a block. None of that comes over, and it's really annoying. I don't know why no slicer seems to support this. If you know any that do, please leave it here in the comments, because OBJ will work, but it's a way older, less good format than 3MF. 3MF is much more efficient, you can store more information in it, and it's far more widely accepted than OBJ for 3D printing. But until that day comes, what we need to do instead is save this off as an OBJ, like this. And then when you load that OBJ into Bamboo Studio or Orca Slicer, you'll be greeted with this window. Now this is really important, don't skip through this, because this is how you're going to pass those different colors, the different materials, into the colors or extruders you have on your printer. And if you just say OK, it'll give you these additional extruders that your printer doesn't have, right? So what we're going to do instead is match up the different extruders you've got to the different colors. So the 6 is this green, but I'm going to choose 1, which is the extruder 1 on the Snapmaker. And then this 5, I'm going to just choose 2, right? So extruder 1 and 2, and then say OK. And this is the result. Isn't this cool? So it's actually preserved the colors, and there's no dodgy geometry trick to make it work. They are perfectly in line. And you can use it to create complex multicolor models that when you bring into the software, you can then assign the different colors to it. So if I go to slice it, it's only adding the color where it's needed to make sure that it's saturated and clean enough without all the complexity of the multi-body approach and without the dodginess of doing very, very shallow extrude cuts to define regions. Each method still has its pros though. I would say if you want to do multi-material printing, do method 1 with a multi-body approach. If you'd prefer to paint in colors or extruders in the slicer, do approach number 2. And I'd probably say if you want to distribute files for multi-color printing where the end user can't stuff it up and doesn't really have to do anything except load it in, assign the extruders and print, then maybe try the OBJ approach. It takes a bit more setup in the CAD program to get right, and you have to add those different materials, color them, and that sort of thing. And OBJ isn't the best format, it's very old, but it's definitely the easiest when it comes to just loading into the slicer, assigning those colors, and then hitting print. Okay, so let's talk problems and solutions. You might come across a vector like this. This is a really bad SVG. It's made up of a lot of overlapping lines and some that aren't fully connected either, even though they kind of look like they should be, which leaves you with these weird profiles that don't quite work. So for example, if I zoom in here, this profile, you can see it's got this like extra line there. This one there has this little extra bit there, and this one doesn't work at all. So if you're bringing a vector in and you want it to be solid, and you're noticing that you can't select the boundary, that's really annoying and very difficult to fix and figure out where it's actually not working. So my method of troubleshooting this is to just grab a line and draw it across the part like that and figure out where the break is. So you can see that it's actually down this other end somewhere. So let's bring it down there. And that means that's probably here, right? And without an enclosed profile like this, you can't use it to create solid geometry. You can create surfaces, but they won't form solid geometry, so you can't actually use it to create a region of color. So you need to fix it. You could either just do this sort of thing, where you move it to where you want and then do it like that, or you could choose to unfix these lines. I could right click, unfix, and I could try to figure out, okay, well, what's broken? These tiny lines there, don't want that. You can see all these overlapping lines. This is terrible, terrible practice, by the way. This is a very broken SVG. And then I could say, okay, I want this one to go from there to there. All right, fine. Now that's a fixed region. But again, you want to make sure that your crappy SVG doesn't get this far. So check its validity in your vector program by turning off the fill and turning on the outline to check that it's creating a nice clean outline that you can use within Fusion. If your SVGs aren't importing at the correct scale, again, remember, you need to make sure you choose the correct DPI of 96, and you need to make sure that your documents are using the pixel unit. Alternatively, if you're having tons of problems with getting your SVG to be exactly the right size, you can choose to import a DXF instead. Now, I personally find that a DXF import is a lot clunkier and it tends to lag up a bit more, and it's a lot less flexible and forgiving for complicated vector images. But when you import a DXF into Fusion, into a sketch, it does let you choose what units it's going to use to set it at the correct scale. So you can be a lot more precise with a DXF right off the bat without worrying about all the faffing of DPI and pixel units, even though we want millimeters in the end. And to insert a DXF, you go to Insert, Insert DXF, and then make sure units are matched up. So millimeters, say OK. And that's brought DXF vectors in, which you can use in exactly the same way as SVG vectors. Finally, I just want to say a few words on the tracing bitmap tool in Inkscape. It is really powerful, but it can also create really unwieldy vector files really quickly. And you need to be aware that some images and some vectors that you create just won't be suitable for creating multi-material or multicolor 3D prints. So what I have here is an image from the original Yamaha DX7 patent. And I can trace this totally fine using the brightness cutoff option and delete the original. But if I show you the nodes, it's like more nodes than image, right? And that's going to make it really, really clunky to import into Fusion. You really want to remove and reduce as many nodes as possible, especially considering that this is mostly straight lines. But arguably more important than that is the fact that this image just isn't suitable for creating the multicolored data because it's not thick enough. The details aren't bold enough to separate. So for example, if I have this at a certain scale, let's say it's, again, 100 high, there's no nozzle in the world that's going to be thin enough to create these lines, right? So in this case, if you want this keyboard shape, you're probably better off just manually tracing it using the different tools in your vector editing program. But if you get the right combination of your vectors and colors, you can get amazing results. And I'm using these workflows more and more for my models because you can take a simple, fairly plain 3D design and just make it pop with a bit of customization. Like this little combat robot, it's part of our Australian plastic ant weight class. So the whole thing has to be made out of PLA. It's pretty boring without the branding, but I created this text within Affinity Designer and I tweaked it to my liking, and I even added an offset to make it match the branding of my favorite Australian chocolate bar. And it just turned out so, so good in multicolor. I'm really, really addicted to doing this sort of thing now that it's become so much easier on modern tool changer and 3D printers with AMS systems. Because again, this sort of thing wasn't possible just a few short years ago. It was too difficult and too wasteful. But now I can really use it to level up my 3D prints. Because here on Maker's Muse, it's my aim to empower your creativity through technology. And if you haven't already, then maybe consider subscribing. I'd love to have you on board. Catch you later, guys. Bye.